Let's get started. Welcome to the first breakout session of the afternoon. Failover Clustering 101. This is one of the breakout sessions we have in the Windows Server track. My name is Jeff Hughes. I'm a Senior Support Escalation Engineer in Microsoft. I started in 1999, so I've been with Microsoft almost 12 years. I started out in dev support, working for SQL, and then shortly after moved to platform support. We were just sort of transitioning from NT 4.0 to 2000, so I've been working with failover clustering since NT 4.0.
Hello, my name is Amitabh Tamhane, and I'm a program manager at Windows Server Failover Clustering product team. I've been at Microsoft since 2008. Before, I was also a developer in the Failover cluster team, in the same product team. And I've been working in this clustering space for about 7 years. Thanks.
All right, show of hands. Who has had some experience working with failover clusters? Okay, 2003? 2008? Okay, good. So what we're going to talk about in this session, really the 101 part is to give you a good foundational understanding of clustering technologies. We're going to talk about some of the hardware requirements and software requirements, what you need to have ahead of time before you implement failover clustering. We're going to go over some core cluster concepts, some things that really help to understand as being a server admin. Go through a demo of actually deploying a failover cluster. We'll deploy a highly available service and kind of give you an idea of how we go through the process of going from scratch, really from nothing, to deploying a fully functional failover cluster in the course of this hour. So my goal is to, number one, show you how easy clustering is. If for those of you that had your hands up from 2003 to 2008, you'll know we've made a significant change and a significant effort, really, in trying to make clustering accessible to the IT generalist so that if you know how to install a printer, you should be able to do that on a cluster. If you know how to install SQL, you should be able to do that on a cluster with very little learning curve, and I think we did that really well. So I broke the session up into the things that you have to have ahead of time, like what do you have to put together, hardware and software-wise, before you start thinking about creating your cluster. What does it mean to actually deploy a cluster? And then once I've built it, how do I make it do something? So the definition of a failover cluster is a group of 2 or more interconnected servers working together to provide high availability. High availability is the whole key to failover clustering. There are other cluster technologies out there in Microsoft. There's compute cluster. There's network load balance cluster. All those have different functions and roles in the high availability environment. But for failover clustering, the single goal is to keep your systems up and running. Clustering does not do anything like massively parallel computing, like some of the products we have like HPC. Primarily, we're focusing on the Microsoft applications that you deploy in the environment, Exchange, file and print, so forth. So the goal with clustering is maximize your uptime. At the bottom, I have a chart kind of give you an example of if you're looking to achieve 5 nines, how much downtime can you afford per year? So that'd be 5 minutes. So if you've got a server, let's say I've got to patch it, and it takes that server 10 minutes to reboot, am I ever going to achieve 5 nines? No. Even if I look to go for 99% availability, that sounds pretty good. But what if those 3.7 days in a row are downtime for the CEO's Exchange server? We're not going to have a happy environment. So the goal of clustering is to try and maximize that equation. The closer we can get to those 5 nines, the better. So some of the sources of downtime, if you kind of think in the environment what normally could take down a single standalone server, those are exactly the kind of things that clustering is designed to protect against. So you can have data corruption, whether that's the local drives or the shared storage that you're using. Component failure, real common issue in the environment where you might have an HBA failure, motherboard failure, application level failure, an application crash. Human error. I powered off a server and I didn't mean to. Then there's also the maintenance. That would be the planned downtime that you have in your environment. Whether it's you have once a month that you do your patching cycles or maintenance you need to do some quick deployments of some security updates, as well as a site outage. So clustering, if you think of that as kind of a server protect, we also can expand that out into the multi-site environment where I have nodes in different sites so that if I have something as severe as a catastrophic site failure, clustering can help recover there. So I want to give a very high-level overview of what happens in a failover. I have 2 nodes in my cluster. I have a group of clients that are accessing an application on server 1. And in a cluster, all nodes of the cluster communicate with each other with heartbeats. They're essentially just each node telling every other node in the cluster, hey, I'm here. That's all it is. The other nodes in the cluster are expecting to hear that from every other node. So that's how we do our detection of, if we stop hearing from one of our nodes, then we know something is wrong and we might want to start to think about what kind of recovery action we're going to take. So let's say in this instance something happens with server A. Blue screens, power failure, something goes down to that. Notice that the heartbeat stopped. So node 1, server 1, is no longer telling its partner that I'm healthy and alive. When that server goes down, the first thing the clients are going to notice is that, hey, I just got disconnected. So if I was connecting to my file shares or my Exchange server, I just lost connectivity. But at that very same time, server 2 detected something was wrong. I'm not hearing from my partner. Is that because there's a network problem between the two? Did he really go down? Well, that's what I need to determine. Once he determines that his partner is down, he pulls that application over to him. And then the clients reconnect and resume whatever they were doing. Okay, so that underlying concept is the same whether we're talking a print cluster, file cluster, Hyper-V cluster. That's essentially what happens. Now, we can have more than one node, but just to understand the fundamental failing back and forth, 2 nodes is the best example. All right, so if any of you went through the process of procuring a cluster in 2003, you had to make sure that the components of the cluster were all on what was called the cluster hardware compatibility list. And that was where every vendor that sold clustering had to put together the pieces and parts, the Cerberus, the SANs, the HBAs. They had to put that together, submit it to Microsoft to make sure it was certifiable as a complete cluster solution. Because of the exponential amount of combinations you can have by various vendors, that process became very bulky and became very hard to track, and it was really a pain for us, our customers, and our vendors. So with 2008, the big improvement we made is we got rid of that completely. And as long as you go out and purchase stuff that's logoed for Windows Server 2008, it should work with failover clustering. Once you've acquired that hardware, primarily the storage, the network interface card, the host bus adapter, and the server itself, you can also add on top of that things like NIC teaming and multipathing, which I'll talk about in a little bit, to enhance that high availability equation. The second piece of this, in order for you to, before you put a cluster into deployment, to make sure that you are comfortable that the cluster is going to do what it's supposed to when it needs to do something like recover from a failover, is run the cluster validation. Prior operating systems, you had a long checklist of things you had to go out and do and check and kind of piecemeal to make sure things were working. 2008, we built that into the product. So prior to installing clustering, and we'll do a demo of that, you run the validation. And that basically automates the entire sequence of going out there and checking and making sure you did things right. If it did, it gives you a thumbs up. If not, it'll give you a very actionable list of things to do to try and fix. Okay, what do I need as far as a network? As you saw in my diagram, there were 2 networks between the 2 nodes. That's kind of what I would consider to be a minimum requirement. You're going to have your network that your clients connect to, and then you're going to have an internal network that the nodes talk to each other over. The minimum requirement, what I mean there is that now we at least have 2 paths between the nodes that hopefully can fail independently of each other. What I mean by that is you probably don't want both of those networks going through like the same switch, or so something where a single component of failure may cause both of those networks to go down. You can add additional networks onto your server to enhance the roles that it does, like Hyper-V live migration. You can have a separate network for iSCSI, a separate network for virtual machine management. But the 2 that I have flagged with the asterisk, that's kind of the minimum requirements. You can get your IP address either statically assigned or DHCP. Whatever you're using in the environment, cluster will support that. And again, NIC teaming, it's a software solution that helps add some additional redundancy against a single point of failure with one network card. As far as shared storage, with failover clustering, we require that you have block level storage. So things like network file shares, NAS servers are not supported. The most common ones you're going to see out in the environment are fiber, large storage array networks, iSCSI, serial attached SCSI, and one of the new players that we recently logoed for 2008 is fiber channel over Ethernet. And it's a really cool technology that allows a single connection between a server and a fiber channel switch, so network traffic and storage goes over the same pipe, and then the switch decides where to send it from there. So one of the options for shared storage is iSCSI. So prior to iSCSI, if you wanted shared storage, you kind of had to go out and purchase some fairly high dollar components. With iSCSI, you can now take virtually any Microsoft server and turn it into a storage server. It also provides storage for things like Hyper-V. So I can install the iSCSI software in the target and use the disks that target server is providing as storage locations for things like highly available virtual machines. It is free. It's downloadable. The only way you used to get it prior to this was in Windows Storage Server. So I'd really encourage you to go download it and play with it. Because like I said, if you don't have the money at home to go out and purchase yourself a storage array network, iSCSI is a great solution not only for the production environment, but for you to get out there and kind of play with this yourself. Just wanted to give a quick overview of how the iSCSI target and initiator environment work. So I have two servers. One server I have the iSCSI software installed. The other server I have the initiator software. The initiator software is included on all versions of Windows Server 2008. My first step is to go to my target server and create a VHD. All this really is a file on that server. It can be stored as a local disk, or I could store that VHD on a locally attached drive, a SAN, a network attached drive. It really doesn't matter. It's just a file. Once I've created that disk, I then present it to my initiator. This would be analogous to if I'm going into my SAN and I'm presenting, I'm zoning a disk from my SAN to one of my servers. The initiator software sees that and detects it as a new local disk. It doesn't look any different to the OS. The OS has no idea where it's getting this disk. The two versions of software that support failover clustering are Data Center and Enterprise, both in the core and full editions. I don't know if when you noticed, when you install Server 2008, you're kind of presented with that list of options to do either full or enterprise, and you have all the different SKUs there. Core is the, I'll talk about that in a second, but that's one of the options you have that supports failover clustering. We also now have Hyper-V Server 2008 R2, which is a free download. It is based on the Server Core UI. But it also supports failover clustering and Hyper-V. So who's worked on Server Core? Handful of people. Best way I can describe Server Core is a core OS that has kind of been stripped down. We've removed a lot of the components that you typically come across in a full server edition. The media player, Internet Explorer. A lot of these things should bubble up as these are things that we typically put out security updates for, like buffer overruns in IE. If we remove those from the core OS, then there's less things to patch. We don't have to worry about patching things like that. By removing them, we've also created a smaller, what's called an attack surface. So all those gremlins out there in your environment that are trying to potentially do harm to your server OS, they have a much smaller portal to try and get through because they don't have all these components that they can try and come in on. So it's also designed to be more secure. Because it's more secure, because it requires less patching, and because it has less things to fail, it also can remain highly available longer. If you don't like the command line way to manage Server Core, we do have the ability to manage Server Core remotely via the RSAT tools. I wanted to give you guys a sneak peek of the new UI for the next version of Windows for Server Core. I don't want to see this screenshot up on anybody's blog or Facebook page. I want to see how many people actually started to pull their cameras out on this one. Whether that actually looks like the real UI in Server Core 2008 and versions after that, I'm probably guessing it's going to look very similar to that. But if you haven't seen Server Core before, that's it. That's the UI.
Thank you, Jeff. So as part of the demo, we are going to see how to create the virtual disks and assign it to the appropriate nodes in your cluster so that you can create a shared storage for your cluster. Creating virtual disk is real easy. You just open up the wizard of create disk, you specify the directory you want to create to, and the name of the file. And so here, the two of the disks were already created, and so we'll just quickly specify the size you want and a description for your disk. And you could assign targets which are already created as part of the wizard, but we'll show you how it would be done in pretty soon. So we just created the disks, and back to you.
So we had already created 2 disks. I wanted to not repeat this 3 times. We'd created 2 disks. We've created 1 more. So really, this was all I had to do to prepare my shared storage to present to my cluster. Doing this in the SAN environment, this would be real analogous to going into the SAN administration software and setting up my LUN masking or my zoning and presenting them to nodes or multiple, 1 node or more nodes in a cluster. But you can see with the iSCSI target software, that's how straightforward and simple that is. So you can see the diagram I have in the bottom corner. That's a real simplistic network diagram, but it does work. I mean, that's the most simple network topology you can have in a cluster. It does fulfill the requirements of having 2 networks that fail independently of each other. So in this example, I have each node's public network. That would be the network clients are talking to on a 10.0 network. And then the private network is a 192.168. That's going through, if these are 2 nodes, it can be something as simple as a crossover cable. If it's multiple nodes, even a simple hub will work. There doesn't need to be a reason to put expensive technology into a place where it's not needed. Keeping this part of it as simple as possible is your best route when it comes to keeping that high availability equation. Like I said, you can use either static or DHCP assigned addresses for your public IPs. As long as they have the default gateway configured, the cluster will recognize that as a network that can be used for client traffic. If we don't see a default gateway, we assume that's an internal network and we use that appropriately. In 2003, you had to go through this yourself and kind of decide, and assuming you understood what cluster network roles were, and do this yourself. And if you did it wrong, you could potentially impact what the cluster would do during a recovery scenario. In 2008, it does it all for you. You don't have to decide what the network's roles are going to be. So the steps for preparing online storage, whether we get it from a SAN or an iSCSI target server, the OS is agnostic to that. We don't know any difference between the 2. So once we see it as a separate physical disk in disk management, that's really all there is to it. We online it, we assign it, or we initialize it as either an MBR or a GPT disk, create a new volume, format it, and then really it's ready to be used by the cluster. So for every disk that I have that I intend to put into my clustered environment, I would go through the same process. The thing to remember about presenting storage is you never want to present storage, the same storage, to different sets of clusters or other standalone servers. The reason is once we have them in a clustered environment, we have a mechanism to control exclusive access. If you have some other server out there or cluster that can see those disks, you potentially risk multiple servers seeing the same disk at the same time. That'd be bad.
Thank you. So now that we have already created the 3 disks, and to save time for the demo, we already have 2 iSCSI targets, node 1 and node 2, corresponding to each of the nodes in the cluster that we already created. And all you have to do is just add existing disks to the node, and you do the same thing for node 2. Here it just prompts that you're assigning the disk to 2 nodes, and so you know that you are going to use the 2 disks in a clustered environment. That's all it's pointing correctly. So if you go to node 1 in the disk management, you can see those 3 disks are, the OS detects it as regular disk. There is no difference in terms of whether it's a iSCSI software or a SAN-based disk. And as we quickly mentioned the steps, we'll just online them, then initialize it to MBR in this case.
And one comment about that, you might have noticed that by default, those disks are all left in an offline state. We do that based on a SAN policy we have in 2008, so that in a clustered environment, we don't automatically online disks, which is the same thing I talked about. You don't want to assign multiple disks to multiple clusters or multiple independent servers because we don't have any way to control exclusive access. By making the default policy for a new disk as it arrives to be offline, we leave it up to the user to decide what node he's going to online those disks and bring them into the clustered environment.
And thanks for pointing that out. And we could do the same steps from node 2. In this case, we are just choosing node 1 to format the disks. And you could select whatever drive letter you want. In this case, I'm just defaulting to the OS selection. So in just a few steps, we have now 3 disks are made available for your cluster as shared storage. Thanks.
Okay. Thank you. Okay, now we've talked about the pieces and parts. We've talked about what do you want to do to get your storage, what kind of storage do you have to use, what kind of, some networking considerations. Now we're going to put all the pieces together, and the diagram on the right side of the slide is essentially kind of the simplest cluster diagram I could create. It's a 2-node cluster connected via, both nodes are connected via a public network and a private network. There's also a domain controller on this network. You have to have cluster nodes in a domain. And then the iSCSI targets that are coming from the domain controller. So essentially, I have built a 2-node cluster out of three servers. This diagram, whether it's physical, whether I actually have real machines out there, or this can be done in Hyper-V. In fact, the demos that we're running today are a cluster that are running off of my laptop. So this is stuff you can take home and build yourself. We talked about some of the ways that cluster provides resiliency, meaning if one server fails, the other server can take over. If one NIC fails, we might detect that as a failure and move applications to another server. Anytime we have a failover, the client experiences that as downtime. So my goal as a cluster administrator is to try and minimize that downtime. Just by deploying a failover cluster, I want to make this clear, is that your high availability equation is not complete. There are still single points of failure, even with the stuff you get out of the box. If you have a single HBA, that's a single point of failure. If you have a single switch that each nodes are attached to, that's a single point of failure. So don't expect clustering to maximize your high availability just magically out of the box. There's some things you can do to add on to that equation. Some of the examples are, like I already mentioned, NIC teaming, which is a software solution that takes 2 or more physical network cards and virtualizes them to the OS to appear as one. The underlying software handles all the, well, what if one NIC fails, then I reroute network traffic on the other. That all happens transparently to the OS. So ideally, we should have a failure but have it not affect anything. That's what you want to consider is if I'm looking at my cluster, how can I protect against all these individual pieces and parts from one individual failure affecting my availability. On the storage end, we have things like hardware RAID, RAIDing disks together so that a failure of any one particular spindle would not affect your storage. Switch fabric, so that if a path between the server and the storage fails, I still have another way to get through. Software multipathing, which if you understand the concept of NIC teaming, it's the equivalent with taking 2 or more host bus adapters, which is how we get from the server to the storage, consolidating them into what the OS thinks is a single adapter, and also providing some resiliency at the component level. Some other things, backup power supplies, doing server level backups, data level backups, SAN replication. This is where we get into some of the more expensive hardware where we actually have another SAN somewhere else where we're replicating the entire SAN from one site to another. Again, these are all things that, in addition to clustering, you have to take into consideration and kind of piece together your high availability solution. And if you do it right and take all this into consideration, that the 5 nines is not unattainable. So now we've got the pieces and parts together. How do we deploy a cluster? So I mentioned something about validation. Basically, we took all the knowledge we've ever had from 2003 to 2000, NT40, all that documentation, all those articles, all those white papers, all the best practices, and we built them into the product. So that when you run validation, we're doing a comprehensive test of about everything you can check in the environment to make sure you did something right. If you didn't do something right, then we flag it. Now, depending on the severity, if it's something that will not affect the functioning of the cluster, we'll flag it as a warning. And we'll tell you, you have your networks configured this way, clustering will still work, but you may want to fix it. We also may detect more serious problems. Like if you can't connect to your storage from all nodes of the cluster, that's going to prevent disks from failing over from node to node. So we do some extensive testing of the storage as well. A lot of customers kind of think that you have to run this and pass it to get support from Microsoft. Validation is for your peace of mind, not ours. We would never turn away a customer if we found out their validation failed. We may have them run it again until we got it to pass. But if you're going to go through the trouble of deploying a cluster solution, why would you want to skip this step? Just so you didn't have to deal with any errors that it might flag. This is the piece that you run before you deploy a cluster. It's going to tell you exactly what you need to go out there and fix in your environment so that you can have that cluster working and working as designed when and if you need it. In addition to running the validation when you are first deploying the cluster to make sure everything is configured right, it's also a great tool to run when you make changes to the cluster. If you add a new node into the cluster and present that shared storage to that node, you may want to run validation again to make sure you did that right. I've seen it 1,000 times where they add a new node into the cluster and they thought they presented storage to the other node, only to find out they did it wrong when the first node in the cluster had a catastrophic failure. So you want to do this ahead of time, make sure things work. It's also a great troubleshooting tool. You make some change on the SAN, and all of a sudden your disk stopped coming online. You can run the validation, and we'll run this rigorous set of tests against your storage and potentially flag what might be wrong.
Thanks, Jeff. So we are going to switch to the Failover Cluster Management UI. And so as soon as the UI starts up, it gives you a nice handy link for validation of the cluster. So you can run this before you create the cluster. So in this case, you just mention what nodes your clusters are going to be. So I'm selecting node 1, which is the demo node in this demo, and I'm selecting node 2. Typically, you should run all the tests, but in interest of time, I'm just going to select. And so this kind of lists all the various tests it does on all the nodes you specified. I'm just going to uncheck a few tests. For the storage, it validates disk failover and identifies which are the potential disks and whether all the nodes can arbitrate for the disk, but we are going to skip that in this demo. And
so the reason we skip the storage test here is it takes a long time to run. We're doing some extensive tests against the storage. Even in this environment, if we didn't include it, or if we did include the storage, it would probably take about a half hour to run. And that doesn't make for good demo material, have you sit here for a half hour and watch that. So the only reason we removed it is just for the sake of time here. But that is probably the key test that you do want to run when you're ready to put your clusters into, ready to deploy them into production. Is that's when you identify that the storage either is going to work or may not work, and you may want to work with your vendor to figure out what's going on.
So you can view the report and you can see the result of the validation. And here it lists that all the inventory test and the network and the system configuration it has run. The yellow mark is the warning, and you can easily click through it as to what's the warning about. And if you select network communication, it says there is only one pair of interfaces in which the two nodes can talk to each other. And so that becomes your single point of failure. And so in a production environment, as Jeff already mentioned, you should have at least two or more network paths between the cluster. And that's pretty much the validation.
The key about the validation, and the thing I really like about it, and the thing that we put a lot of effort into, is making sure that if we find a problem, that we give you very specific and actionable things to go do, not just a generic, hey, network failed, something's wrong with your disks. We really tried to take, like I said, the experience that we've had over clustering all the way up from NT4.0 and build that into this test, so that the responsibility of making sure all these pieces and parts are configured is in the validation, not in you having to go dig through tons and tons of white papers and tech articles, things like that. Okay, so as a user, what kind of domain roles do I have to create a cluster? I either can be a domain admin, in which case I don't require any additional rights or changes in the domain. If I'm a non-domain admin, I do need to be logged onto the domain with a domain account that has administrative privileges on every node in the cluster. The reason we do this is there are some things and changes we make to, for instance, the firewall. We plumb the firewall on all nodes of the cluster. If you're not a local administrator, you may not have the rights to do that. So you need to be a local admin. It can either be through a group, you can be in the administrator's group, or you can be specifically, as long as you have local rights on that server on all nodes of the cluster, you're fine. When we create the cluster, it goes out and actually creates computer objects in Active Directory. If you're a domain administrator, that right is already granted to you. If you're a domain user, you may not have the right to go out and create computer accounts in the domain. Just like when you build a real physical server and you join it to a domain, you may not have the rights to do that. So if you're a non-domain admin, you need to be given those rights when you're installing the cluster. When you first install the cluster, the security context is you, the user. So once we're past that, those are really the only rights you need to take into consideration as far as installing the cluster. Those are the two rights that you manually create. One is create computer objects, and then the read all properties. So it's done through Active Directory users and computers. So when I first deploy a cluster, I'm the administrator. I log on to one of the nodes with the appropriate rights and permissions. I run the create cluster wizard, which goes out and creates an object in Active Directory. Now, this is not a real computer object. It's really just a placeholder to allow Kerberos to function. The first object that's created by the cluster is called the cluster name object. It's really the security context for everything that the cluster does after that. So the next time, now I've created the cluster, it's not doing anything yet. The next time a user who has rights to the cluster comes in and runs the wizard to do something like create a highly available service or application, the security context is not the user, it's now the CNO or the account that we created earlier. So for every service or application I deploy, I'm going to get a new virtual computer object in the domain based on the security context of the CNO. Now, do you really have to know this is all going on behind the scenes? Not really. But what you do have to know is if you go into Active Directory or if somebody doesn't know what those are, like your Active Directory guy looks at them and says, I don't have any machines called those two, so he deletes them, you've destroyed your cluster. So that's a big no-no, is don't touch, particularly the CNO. Because like I said, that's the security context for the entire cluster. So it's basically a four-step. Is there a question? No. So like if you wanted to rename either the CNO or the VCO, that's all built into the UI. What you can't do is rename the nodes. That's a little more complicated process. But as far as when you create the cluster name, the UI has a way to go in and just rename. So the question was, there was no restrictions to OUs. Like I said, they're computer objects, but they're not real. So obviously, any kind of machine policy you have out there is that you're applying is not going to take effect. Generally, what we recommend is that you create your own OU for cluster objects and just block inheritance. That way, you know what they are. You can kind of keep them administratively separate, and less likely somebody's going to touch them. But like I said, because they're not real machine objects, policies don't get applied to them. They're just merely there for Kerberos to work. So when we create the cluster, first thing we need to do is add the feature through the Add Features wizard. We run the validate, which we've already shown you. We run the create cluster wizard, where we enter the data about what we want this cluster to look like. And then we run a wizard to make whatever service we're deploying highly available. So it's all really wizard driven. That's the point I want to get across here, is that in the demo he'll create a cluster in four next clicks, whereas in 2003, you're probably talking a couple dozen steps, any one of which along the way, if you did something wrong, you might not end up with something you like. So it's really easy to deploy.
All right, thank you. So to create a cluster, again, there is a handy link, and it starts the wizard for you. And again, we have to now specify the nodes you are going to add. To the cluster. As part of this step, it does basic validation, like whether the Failover cluster feature is installed on the nodes. It recommends to run the validation, but we are going to skip this.
One thing I want to mention about that last slide. If you had run the validation and it passed, you would not get that prompt. So we know whether or not you actually ran validation. We give you one last opportunity to say, I don't remember the verbatim, but it basically says, I don't want support for Microsoft, so I'm just going to plow through and don't worry about the validation. So because it's a two-step process, we store that file for the validation as a log file. When we run the create cluster wizard, we know if you ran it or not. Now, we won't block you from installing if you haven't run it, but we do provide you some actionable information that may lean you towards getting it to run to where you've had it passed. Yes?
So in this step,
earlier, did you say that if you haven't run the validation test, that you still can get support from Microsoft?
So the question was, if you haven't run the validations test, can you still get support from Microsoft? The answer is yes. We're not going to hang up on you and that's not going to be the first question out of our mouth is, did you run validate? And if you say, no, I didn't, you're going to hear a dial tone.
So despite all the warnings that say that you are giving up support, you're just not really interested?
The key thing I want to make a point of is that validation is for your peace of mind, not ours. If we see the validation hasn't been run, we're going to help work you through the problem. And running validation we may require you to run validation at that point. And that may bring to the surface what the real problem is. It also may eliminate a whole bunch of stuff. So it's a valid troubleshooting tool for us. But there are just some things, especially in the SAN environment, that we can't expect customers to figure out how to fix all the validation errors. So when they do come into us, yes, we'll support them and we'll give them help. But it's for the customer's peace of mind, not ours.
so you specify the name of the cluster and specify the IP address using for the cluster name, network name. And it just summarizes the information for you and now creates the cluster. Even though the two nodes have only one network connection between each other, it still lets you create the cluster. But it's, again, as Jeff mentioned, those are, as it identifies it ahead of time for you.
So this is the part where we're going out, we're creating that object in Active Directory. We're testing to make sure that the IP that he entered is not already existing on the network. We're going out and registering that name with DNS if that name that we input is checking to make sure that that's not also already existing in the environment. It doesn't take very long to run, because all the real hard, heavy-duty stuff we've already done with the validation. This just sort of puts it together.
Yep.
We get a nice report, which let Amitabh kind of walk through.
Yeah, so it kind of lists all the basic steps it does, and it's, as Jeff mentioned, it creates the demo class computer object, then it validates clusters disk driver as well as the NetFT driver, and creates the cluster group and IP addresses using which you can connect to the cluster. And so it's basically a nice summary of the steps it has already taken. And if there is a problem, it will tell you at what point it actually hit the problem. So once you click finish, the UI connects to your cluster, and it takes a few minutes when it's reading information. So it loads like the name, and it tells you the quorum configuration as with a disk witness. Currently, we don't have any services and applications. It lists that you have 2 nodes which are up and running. And if you click networks, it shows you the cluster network 1, which is using which you can talk to the cluster. And if you look at the storage, we already added 3 shared storage to the cluster. So out of which it selected the first one as the disk witness for the quorum, and the remaining 2 disks are now available for you for your applications.
Okay, so that's looked to me pretty straightforward. That don't know how many clicks I counted, but all the only information you really had to enter was what are the nodes in this cluster, what is the client name that I'm going to connect to my cluster, and what IP is it using. If I was using DHCP, that'd be one less item I'd have to enter. So creating the cluster, again, a very simple and straightforward process.
In the planning stages or during any of this, there are other concerns you need for VMs?
So the question was, during the planning phase, is there any other concern for VMs? Like if you were planning on deploying Hyper-V VMs on this?
No, you're going to cluster 2 virtual servers.
No.
No.
Because this cluster right now has no idea it's running in a virtualized environment. So the standard caveats with any VM, obviously because I'm running 3 at a time, I want to make sure they all have enough memory. But other than that, in a clustered environment, no. The only thing I will mention is because we don't have any virtualization of HBAs in Hyper-V, the only way you can do shared storage with a Hyper-V cluster is with iSCSI. Now. Yes?
The disk quorum automatically selects first available disk. Is that the default?
So the question was, does the cluster automatically select the witness disk?
Yeah.
We select the first disk that we find that's over 500 megs.
Is there a documentation that specifies the minimum disk size on these?
Yeah. Yeah. Now, in reality, the files that we put on that disk are substantially less than that. But 500 is, I don't even know if you can get away with carving out a 500 meg LUN anymore. Typically, what you're going to want as your witness disk is the smallest LUN that you can carve out at the SAN environment and probably have it mirrored on the back end like hardware RAID. But 500 megs is more than plenty for that. We happen to have 3 disks of equal size, so it just picked one. I can always go in afterwards and say, I don't like the disk it picked. I can move my quorum designation to another. The whole concept of the quorum models is really outside of the scope of what I wanted to cover. But if you do come to a session I'm doing on Wednesday on multi-site disaster recovery and Hyper-V, we'll talk a little bit about the quorum models. But again, cluster knew that you were using shared storage. It knew that you had a disk that was capable of being a witness disk, and it did it for you. It automatically configured everything.
You are already on the...
Yeah. Okay, so now we've gotten the cluster built. We created it. It's got shared storage attached. It's on the network. It's there and installed, but it's not doing anything. It's not serving any purpose. It's just the underlying framework that we've created for us now to make it start doing something. So by doing something, this is what I mean. These are the typical roles you're going to see on a failover cluster. The common ones, those are definitely the big five. I would say those are probably 98% of the applications you see deployed in the Microsoft failover cluster environment. Hyper-V, SQL, Exchange, File Server, and Print. In 2008 R2, we added Remote Desktop Connection Broker as a highly available service and application, as well as DFS replication. Again, stuff that we won't cover in the scope of this training, but just give you kind of an idea of what's available for you to make highly available. And those are the ones that people really want highly available. Your Exchange servers especially. When your Exchange servers are down, all work stops for some reason. One other thing I want to mention is there's the bottom right are some of the generic containers that we've built in to failover clustering so that you can essentially cluster anything you want, whether it's a service, an application, or a script. So out of the box, you get what's listed, but that doesn't mean you're limited to that. In fact, in some of my earlier training I used to do for 2008 and 2003, I would cluster Solitaire. I just create a generic application and I point it to Solitaire, and I power off the machine, and I have highly available Solitaire. Not real practical, but some of the options you have for managing your failover cluster manager, you've already seen a little peek of that in how we create the cluster and run validation. If you're into scripting, clustering and PowerShell, there's a ton of really cool PowerShell commandlets you can use for failover clustering. So if you like PowerShell and putting cluster commands together, everything you see me do and us do in the UI, there's an equivalent PowerShell command line for. Everything also has a WMI interface you can query for. So if you like to kind of develop your own apps that can talk to the cluster and get information from the cluster. You can administer the cluster from a non-2008 server. Like if you wanted to administer from a Windows 7 workstation, you can install the RSAT tools and have Failover Cluster Manager. That Failover Cluster Manager also can connect to a server core cluster. So you can essentially have the UI that you would have on a full edition, but the back-end cluster is just running this bare-bones server core install. Clustering is also tightly integrated with a lot of our System Center products, like Operations Manager. It's got a bunch of health packs you can install that will monitor the cluster, generate alerts, scan the cluster for some best practices. It's really integrated into Virtual Machine Manager. So if you're not only deploying virtual machines in your environment through SVCMM, you can actually take those VMs and deploy them to a cluster. You just say, I want this machine to be on that cluster, and you've got a highly available VM. If you haven't worked with PowerShell, it's a command line driven scripting language, really powerful. Like I said, anything you can do through the UI, you can do through PowerShell, whether that's running validate, create the cluster, or even manage Hyper-V. If any of you worked with cluster.exe, that was a command line that we've had all the way from NT4 on up to 2008. We're deprecating that, so everything that you can do through cluster.exe, the command line, does have a correlating command line equivalent, PowerShell equivalent as well. So now that we're talking about making our server do something, I want to talk about what a cluster group is, because a cluster group is kind of that fundamental container that all the cluster resources to make it do something go into. It's the smallest unit of failover, so when I create a group, that container is going to contain everything I need to basically serve a highly available service or application. Generally, it's going to have storage, name, IP, and then some application. When I fail over, all those pieces fail over together. So if I have multiple groups, those groups fail over independently of each other. There's no cross-group dependency. I can move groups wherever I want them, depending on what my server capacities are. But that's the small unit that we're talking about. A group is what serves the purpose of putting it on a cluster. So when we created the cluster, we gave it a cluster name. That's the name that the admin uses to connect to the cluster if he's using Failover Cluster Manager or using the RSAT tools. That is not a name that you want your clients connecting to. So if you're planning on deploying your a failover cluster with Exchange, you don't want that cluster name to be the one you're intending to use for Exchange. The first one you enter is the one that just you're going to use to administer the cluster. Everyone after that is going to be a new network name and IP pair that your clients are going to use to connect. And each group is going to have its own independent IP and name, much just like how you would connect to a standalone server. So we have a network name and an IP, what it is I'm making highly available. In this example, it's a file server. And where am I storing those file shares? I'm storing them on one of my cluster disks. No. So the question was, does failover capture state? And the answer is no. We move over everything during a failover except for what's in memory. Now, Hyper-V gets a little fuzzy because in Hyper-V live migration, we can actually take a running VM, create a snapshot on one of our partner nodes, start shipping memory over to it in smaller incremental chunks until that machine's ready to actually pop online. That would be transparent. Aside from that, when I move a group from one node to another, the client loses connectivity, so it would be up to the client to handle the reconnect, but whatever was going on at the time was lost. So if I was running a SQL query, I just have to resubmit it. If I was copying a file, I'd have to restart the copy. A failover, other than live migration, is not transparent to the client. That is downtime. A fully production SQL server that's got some huge databases, when we fail over, we have to checkpoint the databases and dismount the disks and move everything over and reverse that process. That may take some time, no matter how good your hardware is. So that's something you consider when you're talking about, when I fail over from A to B just as a planned failover, I need to know how long that's going to take. That's kind of my baseline.
A little bit of addition to it. We have policies in which we can restart applications before we attempt the failover, because usually the failover is considered expensive.
Right. We'll retry at least once on that node. If we fail that, then we'll trigger the failover. So I'll go through that same example I did towards the beginning of the presentation, except this time we've actually shown what a real live environment would look like, where I've got users connected to a file server share that I'm hosting on one of the nodes. The name and the IP, those are different than the node names. Kind of think of that as a floating IP and name, so that the IP and a name that is in that file group can move between either node. So if I have clients that are connected to that server accessing their file shares, and we lose the heartbeat, something happens to node 1, the clients lose connectivity, node 2 detects the failure, pulls the entire group, and brings everything online. And then the clients can reconnect. Again, the time that it takes to do that can vary. If it's just a file server, it may take 10, 15 seconds. If it's an Exchange server and it has to do a lot of stuff, it may take a little longer. But the point is, the time it took to fail from A to B is significantly shorter than it would be if, for some reason, one of the nodes went hard down. Like if node 1 was a standalone server and suffered a catastrophic component failure, I may be down for hours. Whereas in this case, the time that it took to fail over it, that was my only downtime that I incurred. Okay, so the last demo we're going to do is where we actually put a file server into production and show that it's working.
Thanks, Jeff. So in this particular case, we have a volume F disk we're going to use to store the shared file server shares. So all you have to do is just click configure service or application, specify that in this case you want file server. You have a bunch of lists of applications, including virtual machine, if you want to make it highly available.
Now the list of stuff that you saw, that was stuff that you get out of the box. We do not include the resources to do SQL or Exchange. Those applications have their own way of getting installed on the cluster. So this is what you get out of the box, and most of them were on that first slide that I showed you. But again, the reason you don't see SQL or Exchange is that when you install them, those are cluster-aware apps. Those know, okay, I need to go out and do the same thing that I'm doing here.
So here you specify the network name using which you would be able to access the files. Here you just specify the IP address for it. And it asks which disk you want to use. And as mentioned before, we'll just select the volume F. and it would now create resources for you. It would add dependencies in the resources for you. So your network name has to depend on your IP addresses because IP has to come before network name, and your file server depends on network name as well as your cluster disk. You can even see a report. I will just skip that for now. And your demo file server is now online with the IP address we specified, with the disk that we specified. And now if you open Windows Explorer, the disk is now assigned to file server, so you can't see it, but you can now access the share that the file server is at. And you can create directories, you can add files to it.
So do an example of, so previous versions of clustering, if you wanted to cluster a file share, you had to create the folder in Explorer, you had to go to cluster administrator and create a resource that pointed back to that share. It wasn't real intuitive because if you tried to share out that folder through Explorer, the cluster didn't know about that and didn't pick that up so that it could fail over. So in 2008, the whole idea was if you create a file share through Explorer, there should be no difference in how you do this in a standalone server. So go to the, just open up Windows Explorer.
Yep.
Now notice we don't see the F drive. That's because the other node owns it. So what we want to do at this point is do a failover.
In this case, you can just move to node 1.
Now this is a user-initiated failover. I am telling the group to move from node 2 to node 1. The reason I'm doing this is because obviously I don't have access to that drive from node 1 if it's owned by node 2. So I'm just moving the disk over to the node that I'm connected to.
And now the volume is available as part of your regular Windows Explorer. Well,
Okay. All right, so what I'll do is let me show you. Okay, I've got a folder on that drive called users, and I want to share it out. Okay, that was no different in how I would do that in a standalone server. I would just go open Explorer, share out a folder. But if we look in Failover Cluster Manager, you can see that that has now been shared out by the cluster. We've now associated that folder with a clustered resource so that if I do fail over, that share will be intact on whatever node I'm moving that group to. Okay, you don't want to show the connection from the DC?
sure. So this is our node 1, and we'll just go to the DC node and see if we can access that file share. And we have the users folder available for us to access and read from.
Key thing here is that as a client, does that look any different than how it would connect to a local file server, standalone file server? The answer is no. As a client, I have no idea that I'm connecting to a clustered file share. So if I'm a user and I have a share open to that, let's say I have a document in my share. Okay, I'm basically using the DC because I'm trying to simulate what a client would do because I only have 3 machines. But this could be some client out there in the network connected to his file share. And I want to make sure that node 1, so node 1, if I look at my file share group, it's owned by node 1. I'm going to simulate a catastrophic failure by powering off node 1. Okay, now this is not a normal shutdown, because a normal shutdown does take some time. During that shutdown process, the cluster service is going to push anything that it owns off to the other nodes. What I'm going to do is to simulate this node being hard shut down. Okay, if we go to the domain controller, you'll notice that I'm still connected. I still have my document open. If I tried to save it right now and the failover hasn't completed yet, I may get an error that network name is not available. But again, the failover is going to happen fairly quickly. The user, if he has a document open, may not even notice that this is going on. Okay, we can see that node 1, this node, I'm opening up Failover Cluster Manager on node 2, detected that something was wrong, removed node 1 from the cluster, and the new owner of this file share group should now be node 2. So everything that client was using to connect to has shifted ownership to an entirely new server. If I went back to the domain controller, save the file, it's still there. Okay. Transparent to the user.
Question. So
Yes.
basically, if you do continuous pings, and then you check it down,
Mm-hmm.
there's no time out, and it's going to pick up again.
Yeah, so the question is, if you do continuous pings against a cluster IP or name, when a failover is occurring, what you would see is the ping would be successful. As soon as we unbound that IP, we would stop seeing replies. Then as the failover moved to the other node and that IP got rebound to that node, we would start to see replies again. So that time window there, that's your failover time. Now there's stuff behind that IP that may need to come online like SQL or Exchange, but to a client, that's exactly what they would see. I guess the best way I can describe it is, to a client, a failover looks just like a reboot, only quicker. The reconnect option is available much quicker.
Is there still like active, passive failover?
Yes. So the question was, is there still active, passive failover clustering? And quick definition of that is, if a node is hosting a group, it's active. If it's not, it's passive. So in this example here, we have one group, the file share group, being hosted on, in this case, node 2. Once we brought node 1 back into the cluster, node 1 would be passive, node 2 would be active. If I moved the group, like we showed manually doing, that would flip the roles. If I created a new group to where each node owned a group, active, active. Now if I moved, at that point, everything to one node, active, passive. So the active passive description is really just a definition of, is that server hosting client request? It's not really a configuration option you have to choose. Question in the back?
If you disable both private and public make and switch time, what's happening? It's going to trigger the failover?
So the question was, what if I lose connectivity between the two nodes? And in this case, it was, what if I disable the public and the private at the same time? That's something we don't want to do, because we've now created a possibility for the cluster to recover from something. Because we don't have any way for those two nodes to talk to each other right now, and in the example of, let's say we're just simulating a loss of connectivity between two nodes in a cluster, whether it's right next to each other or at a different site, either each node thinks the other node went down, doesn't know what's going on. In reality, is that node up or down, or what is it doing? We don't know, because we've lost connectivity. So we use the witness disk, in the case of the way this cluster, as a means of arbitration. The assumption is, even though they can't talk to each other over the network, they probably can still talk to the storage. And because clustering is a shared nothing model, we're going to assume that whoever owns the witness disk, which is the resource that got created, is the one that owns the cluster. So the way we handle loss of connectivity between the two nodes or sites or groups of nodes is, out of that partition, who has the most votes left. Again, the topic of quorum is something we'll talk about in the failover clustering DR session. But the cluster is designed to recover from that. Question in the back?
Is there any reason why on a failover that a extremely large isolated volume would take a very long time to online?
So the question was, during a failover, is there any particular reason that a large iSCSI volume would take a long time to online? I'm guessing this is a specific scenario you've seen. In reality, what we're doing from the cluster standpoint is not much. We're talking to partition manager and telling the disk to online. Now, beyond the cluster, there's a whole lot of stuff that that disk traffic has to pass through. NTFS, disk, multipathing software. So there's a potential that there could be a delay anywhere once it leaves the control of the cluster down to the HBA, or that delay can occur out there on the network somewhere. So the mere act of bringing a disk online from a cluster standpoint is fairly low overhead. That shouldn't take any time at all. In fact, a disk is the resource that will fail over the quickest. But taking an inordinately long amount of time, I would say that would be an indication of something wrong with the storage subsystem. There's a couple more slides to get through. I do have some Q&A time built at the end, so if we could hold off the questions until then. Is there anything you wanted to talk about?
No.
Okay. There's a session that we have VIR 304, so if you're interested in taking the knowledge that we've talked about today into the virtualization world, we made a highly available file server, but the process for me making a highly available VM so that I can fail over a Hyper-V machine between node to node, no different. I just run through the wizard and say, make that VM highly available. But this session will go into a lot more detail about some of the ways you can design your Hyper-V cluster, some of the benefits of running a virtualized cluster, how you deploy them. But there is a very tight integration between failover clustering and Hyper-V. Up to this point, we support up to 1,000 VMs per cluster. I have not yet seen that. To me, that'd be an ungodly high number to try and administer, but when it can be done, somebody will do it. The eventual goal of Hyper-V and failover clustering is to virtualize the IT infrastructure so that you have one domain controller, your physical domain controller, and some really beefy Hyper-V servers running what used to be physical servers. So if that's something you're interested in, I would highly suggest you go to the VIR 304 session. As I mentioned, everything that you're seeing is being done in Hyper-V on a laptop. So that same network diagram that I showed you at the very beginning of the class on what a cluster topology looks like can all be put into a package in a Hyper-V environment, and I'm running that off of my server, laptop, whatever. We also have a session on failover clustering and Hyper-V multi-site disaster recovery. So failover clustering typically has been a node where two nodes are right next to each other, but we also can stretch that in between buildings, in between cities, in between countries. I've seen clusters where we have nodes in New York and nodes in Dubai. So really the technology there is the bandwidth between the two. If that's something that interests you, building highly available solutions in a geographically dispersed manner, that's a great session to go see. So we've talked about some of the applications that you can deploy through failover clustering. Many of them encompass the enterprise servers that you're running now, Exchange, SQL, File and Print. Easy to put together. As long as you're buying hardware that's logoed for Server 2008, clustering should work. Everything is wizard-based. So when you want to create a cluster, you run the create cluster wizard. When you want to deploy something, you run the create services and application wizard. It's also easy to manage. So when you want to create something, everything is context-driven. If you want to create a service, we drive you through that as well. So back in the old days, most IT environments with NT4 in 2000 on up to 2003 had the cluster guy in the environment. He knew the cluster, but nobody else dared go near it because it was complex, complicated, not easy to understand. The goal of 2008 is to make it accessible to everybody so that there's no longer a need for that guy. So I encourage you, with what we've talked about today, to, when you leave Tech Ed, download the iSCSI target, build one in a Hyper-V environment, and play around with it. Here's some of the breakout sessions related to high availability. We are located down in the TLC in the server and cloud area, so I'll be down there right after this presentation if you want to come talk to me or Amitabh and talk about anything clustering. On the side, we also have some failover cluster resources. We have our Cluster PM team blog, some great TechNet and MSDN articles on clustering. Resources for the various tracks we have at TechEd. I encourage all of you, once you leave here, to do an evaluation. They're giving away Xboxes, Zunes, and all sorts of stuff. So the feedback is really appreciated for all of these presentations. So I encourage you to go do that after the session. Tag is out by the door if you're in that the contest for getting the tags. I'll leave that up there in case anyone take a picture of that. I don't know if that's a live one or not. So at this point, we've got about 5-10 minutes left. Open it up for questions.
What happens if the quorum goes bad?
Okay, the question was, what happens when the quorum goes bad? In 2003, what was the answer? Everything goes bad. And that was something our competitors really like to point to, that is a single point of failure, and they were right. In 2008, that's no longer an issue. It's all about votes. So in my cluster, I have 2 nodes and a witness disk. That's 3 votes. As long as 2 of those, or a majority, is available, my cluster stays up. So my cluster can tolerate a loss of a witness disk. It can tolerate a loss of 1 node, but it can't tolerate both. So I could essentially yank that witness disk away from the cluster. I've still got 2 votes, and my cluster will stay up.
So you can create a new quorum drive?
You can change your quorum disk resource if you want to.
I could present a new one. I could pick one that I already have, use it, switch the witness disk designation to that. All this would be online. The only way you would know it happened is if you were happen to monitoring it for alerts. Okay?
So we have a failover cluster, print server, file shares about 2 terabytes, several tens of thousands of files. Print server hosts maybe 25 or 30 printers. Fail it over, file share comes back up. Less than a minute. Printers take 5 or 10 minutes. Never known why.
So the question was, in a mixed, I guess the file server role here is probably not really part of the question. It's why is it taking my print so long to fail over? Yeah, the reason we do that is, even though the failover itself is not transparent to the clients, any jobs that are still spooling will let finish spooling, assuming this is a planned failover. So we block off any new jobs coming in, but any ones that are still coming in, we have to wait until they're done spooling for us to finally take that group offline and move it. Now, if this were an unplanned failover, we're like a hard shutdown, then we've lost all those jobs. But that's why. Next question.
In a custom print server, is it required to have a spooler on shared storage?
The question was, in a highly available print server, is it required to have the spooler directory on shared storage? And the answer is yes, because that's where we also replicate the drivers so that every node in the cluster, when we fail over, can pick up those driver updates. Yeah. Plus, if they were local storage and you failed over, you would lose all those jobs that had spooled.
Do they have to be the same identical hardware?
The question was, do you have to have identical hardware? The answer is no. As long as they're low-good for Windows 2008, you should be fine. Virtual and physical is fine, as long as you pass validation.
There's one question.
There's a question over there. So the question was, when I fail over, does the iSCSI target reconnect? So inside of the guest itself, when we fail over, that disk comes offline, and we move it over, and it comes online on the other node. The only thing that changed was that the ownership of the disk, since both nodes have the potential to see it, we just offlined it here and onlined it here. Oh, okay. So if you're talking about a local storage that's also presented as iSCSI, that VHD would be stored typically on the same disk as your VHD? Right.
So
You're talking about a pass-through disk.
Yeah.
Okay.
So you've got your virtual machine, and you authorize an initiator inside the virtual machine to your SAN. So your host is not aware of that storage at all. When you fail the VM over, you reconnect using the cards that the customer has.
Oh, okay. You may want to meet me down in the TLC so we can draw this up on a whiteboard. My response is yes, because we're reestablishing that network connection. And the initiator is built to handle the initiator itself is resilient to some amount of loss of connectivity, but not an infinite amount. Okay? Yes?
Whenever you have a wide area network and you have failover, is there an iSCSI device involved in that?
So the question was, in a wide area network failover and you have an iSCSI device?
Right, because I see the iSCSI as a single point of failure, and I'd like to do away with that single point of failure. If you lose your SAN,
Yeah, we talked a little bit about SAN replication, where you have one SAN that your cluster is connected to, and then another one that you're mirroring, and then behind the scenes, if you have a failure of SAN A, you switch the disk to the other node. That's really expensive and really complicated, and is all provided by the vendors. As far as the iSCSI target server, yes, that is a single point of failure, but there are software solutions that do disk replication as well. So we didn't talk about those. So, any remaining questions? All right, we are just out of time, so I appreciate it very much.